So, hello and welcome to the next session on WIPRO special series by Quant Masters. So, in the previous sessions, we went through a lot about object-oriented programming, particularly within C++. And we also consider and know that there will be a lot of questions, particularly on Java as well, which will be our focus in today's session to begin with. Now, before we begin with Java, so the first thing we should all know is that when it comes down to interviews, the first things, the basic things that are often asked about Java is not the practical coding questions. Most of them are theoretical questions that come up like explain this particular feature of Java, or how is Java different compared to C++ in a particular aspect. They may choose whatever aspect to ask. So let us figure out, look at all these things and see how to particularly answer them. Now, the first thing, Java is, as we know, an object-oriented programming language, which is a much more improved version of C++. But there are some things we should know. Java is not a superset of C++. Previously, we had known that C++ is a superset of C. Yes, but Java is not a superset of C++. That basically means that Java has removed certain things that C++ had. So let's try figuring out what are the things that Java has, Java doesn't have, what are removed, and what is it that we should know and we should learn about. So the first question, that first thing that most of us should know about is something called buzzwords within Java, or they are also called as features of Java. Now, when it comes down to this, we may have learnt in textbook that there are a lot of features, but we need to always know this from a practical perspective. So let us see what are the features of Java. There are a lot of them. You may have read 8 to 10 features, but I'm not going to go through all of them. I will only specify just a few for us to understand in brief what it is, how it works, and how we will be able to answer questions on this. So one of the first thing that comes up is, in features, it is portable or platform independent. And another thing that often comes up is secure, robust, and architecture neutral. So these are some major terms that are often asked about Java. Now we know Java is object-oriented programming and everything, because just like C++, Java is also object-oriented programming language. But there are some things which we should know that are different compared to this. So one of the first thing I want to point out is that Java is more secure than C or C++. So first thing they will ask, what are the advantages of Java compared to C++? This particular question can be asked in many ways. So features of Java or advantages of Java compared to C or particularly C++, considering that both are object-oriented programming languages. Now, when we talk about secure, here's the basic thing we should know. What exactly does secure mean? So the basic point we should know and remember here is that back when it comes to, or when it comes down to C++, you have the concept of pointers. With the concept of pointers, you can access outside the memory location that is given to you. We know that using pointers is very dangerous because pointers can access memory locations outside of their given indices. If indices 0 to 5 are given, or 0 to 4 are given, I can access the next memory location also. I can access the previous memory location also using pointers. This makes it dangerous or unsecure because you can access memory that is not allocated to you. So you can obtain some important data and replace it or change it, which may be very important for another program. That is a big problem when it comes down to C++. So in order to solve this here, we have secure concept when it comes down to Java. Now, right, so I assume that there was a So I'm very sorry for the slight delay. There seems to be a slight issue where audio was not available. So I hope it's clear and the screen is visible and I'm audible to everyone. So there's just a slight technical glitch. So with that solved, now let us go ahead and look at this part. So the basic point that we're discussing right now is why exactly Java is more secure compared to C++. So right now, the reason Java is secure compared to C++, it's pretty simple. C++ runs directly on top of operating system. And in C++, you have explicit usage of pointers. When we use pointers, we can access memory locations whichever are not allocated to our program. We can access memory locations outside as well. That is the reason why C++ is not secure enough when you create applications. But when you go for Java, Java doesn't directly run on top of operating system. It doesn't. Instead, Java runs on top of any Java program that you're running is running on top of a Java virtual machine, which is completely independent from the operating system. So if we were to just understand it like this, let's just try understanding with a small example. So if let's say we understand it something like this, this is our Java program which runs on top of JVM, which in turn runs on top of, let's say, your operating system. So if this is your Java program and this is your Java virtual machine and this is your operating system, the Java program doesn't directly access operating system. Plus, it doesn't have the concept of pointers that you can use. What I mean to say is, it doesn't have explicit pointers. You still have pointers in Java, but you can't use it explicitly. You can't use it in a program. It is there in the back end of the program. You can't use it manually. So because of that, you can't go outside your array indices. You can't move outside from the addresses. Even if you do, somehow you will end up in the virtual machine itself. You will not be able to access other memory areas in the operating system part. So that is why Java is considered to be secure. So when this particular question is asked, the reason Java is secure is basically because of two reasons. First one is that there are no explicit usage of pointers. You can't use pointers manually. It's only there in the back end. It's still there because it's built on C++. Pointers still work, but we can't create them in our programs. That's the whole thing. And the second thing is Java programs run on top of JVM, and JVM is a Java virtual machine, which is basically a sandbox. Now, the reason I use the word sandbox is, think about this. Think about when a lot of people go to beaches, they have a box of sand in which kids play. Since kids are very small, they can't go out of that sandbox. So the same term comes here, where every Java program runs in a sandbox called Java virtual machine. That is why it can't go outside and access other memory location. So these are the two reasons why we call Java as secure. Now, one more question that is often asked when it comes down to this is, what is robust, what is architecture neutral, what is portable and platform independent. So portable, platform independent, architecture neutral, I'll explain them together, but let's first understand what exactly robust means. So the first thing is no pointers or no explicit pointers. You still have pointers to remember. No explicit usage of pointers. And second point, there is automatic garbage collection. So what this means is, let's also write one more thing similarly. Java does not have, it doesn't have some certain features. The first thing we got to know is explicit usage of pointers. We can't have that. Similarly, Java also doesn't have destructors. Destructors of functions which run at the end of a object's lifetime. When an object is removed from memory, destructor runs, where you can write code basically which will be executed only when object is deleted, and that will ensure that if you have some variables to be removed, if you have some data which is dynamically allocated and it should be deleted and so on, you need destructors. But in Java, you don't need that. You don't need it whatsoever. Instead, there is an automatic garbage collection using an inbuilt method called finalize. So this inbuilt method called finalize automatically deletes whatever is unused, whatever is not needed by the class, or objects are not needed, it will delete the objects as well. So this is what makes Java robust. Robust basically means it's very powerful. That is the basic meaning of it. Powerful or strong, you can call it whatever you want. So because of these two major reasons, it's considered to be powerful or strong. Now let's go ahead with the next one. See, these don't mean the same. When they ask buzzwords or features or what is better in Java when compared to C or C++, don't think that portable, platform independent, architectural neutral are all same. They're not all same, they're different. And I'll start with one thing at a time. Let's start with architecture neutral. If you remember, back in C or C++, when you have an integer variable, the size of the integer variable used to depend upon the architecture of the system. If the system has a 32-bit architecture, size of integer will be 2 bytes. If the system had a 64-bit architecture, sorry, one minor mistake. If the system had a 16-bit architecture, size of int will be 2 bytes. If the system had a 32-bit architecture, the size of integer would be 4 bytes. So size of integer would differ based on the architecture of the system. Whereas in Java, immaterial, it is neutral to the architecture. By changing the architecture, it doesn't change the size of any data type. That's a basic thing that we just should know when it comes down to architecture neutral. So there are no architecture specific implementation features. It's same for all architectures, whether 16-bit or 32-bit. This is basically called architecture neutral when it comes down to Java. Now, followed by this, let us go on to the next part, which says portable and platform independent and so on. So, when we talk about portable and platform independent, let's first go to platform independence and then learn what exactly portable is. Now, when I say platform independent, C and C++ are platform dependent. What I mean by this is there's this concept called write once, run anywhere. It's called WORA. This is the feature of Java. You can write a program once. That is, you can basically compile a program once and you can run it anywhere, any amount of times. Now, let's try this out. So, Java is platform independent. Let's see how exactly it is platform independent. Now, you have C and C++. Now, in C, when you write a program or when you compile a program, it's going to create an exe file. In Windows, in Linux, it's going to create a .out file. Same thing happens with C++ as well. But in Java, when you compile a program, whether it's C or C, whether it's Windows, Linux, Mac, it doesn't matter. It's always going to create a bytecode with extension .class. Its extension is always same. So when you create this .class file, you can take it to Windows also, Linux also, or Mac OS X also and run it. Whereas in C, if you create the program in Windows, you can't run it in Linux. If you create the program in Linux, that .out file can't run in Windows. This is what is simply called platform independence. So in Java, there is platform independence. So Java is platform independent. However, JVM is not platform independent. Now, why is JVM not platform independent if Java is? So there's a simple point here. JVM talks to the operating system in order to manage memory. If JVM is supposed to manage memory, the way memory is handled and managed is different in Windows, because Windows has a different memory manager service and Linux has a different memory manager service. That is why only Java Virtual Machine, JVM, is platform independent. But the Java program that runs on top of JVM, that is not platform independent, that is not platform dependent. Only JVM is platform dependent. Whereas Java programs, the .class file that are created from your .java file or .java file itself, if you want to run directly, they are not platform dependent. They can run on any platform, but for each platform they have to run, they need the platform specific JVM to run on. So that is why JVM is platform independent, whereas Java is not platform independent. So this same concept is also called portable. I'll just state platform independent and portable are not much different. Its same is called portable because the compiled Java program can be or can run on any other platform. So it's portable. So there are a lot of other features as well, that it is distributed, it has multi-threading and so on. But these are the main things that you need to know. And when they ask you how is Java better than C++ or why is Java better than C++, you can take a look at these features and explain them. It's secure, it's robust, it's architecture neutral, and it's platform independent portable as well. Now, with this, let's look at what Java doesn't have. So we know that Java is an improvement from C, but it doesn't have a lot of things. So these include go to and label statements, which were there in C and C++. It's no longer there in Java. And we also learned one thing, that was multiple inheritance in C++. That is not there in Java as well. So you do not have multiple inheritance in Java as well. Now, everything that we are stating here are the things that we do not have, not what we have. So that is why I state explicit usage of pointers, because pointers still exist, but it is restricted only to the backend. So followed by this, the other thing we need to know is Java is compiled as well as interpreted, which I'll state ahead. So Java also doesn't have some other features that C++ has, including reference variables. We know C++ has reference variables, whereas Java doesn't. Similarly, Java also doesn't have structures and unions. These are also not available in Java. Followed by this, we should also know, along with this, we had a few other keywords, including virtual, which Java doesn't have. So these are just a few things that C++ had, but Java no longer has. Also, we have something called default arguments within C++ and Python, but they're not available in Java. So these are just a few things that we need to know. So followed by this, now that we got to know, if we get a question saying that asking what is the advantages of Java compared to C or C++, we can easily answer this. If we get a question saying what is difference between Java and C++, what does Java not have that C++ has, we can easily answer this. Now, when you talk about what does Java have that C++ doesn't have, Java has that C++ doesn't have. In terms of regular terms, this exact thing can be stated: architecture neutral, platform independence, portable, and so on. Along with this, you have a few keywords, you have a few features, like you have super keyword, particularly you have final keyword, and you have a lot of other things, including abstraction. And abstraction is implemented in multiple ways when it comes down to this, including interfaces. There are many other ways by which Java has some things that C++ does not have. So going ahead from this, let's now move ahead to a few other important concepts that we need to know when it comes down to Java. So first thing, there are a few basic terms that we need to know, and these terms are JIT, JVM, JRE, JDK. Let's try figuring out what these are. JIT stands for just in time compiler. JVM stands for Java Virtual Machine, and JRE stands for Java Runtime Environment. Finally, JDK stands for Java Development Kit. Now, just-in-time compiler is the compiler which runs your program. Now, here's one tiny little aspect which a lot of us forget of at times. JIT, when it comes down to Java, it doesn't only compile. It's not just a compiled language. It's also an interpreted language. Java is a compiled as well as interpreted language. Now, how is this? How exactly is it compiled as well as interpreted? Now, when we see any Java file, we have a .java file here. Let's just take one example for us to learn in real right away. So let me just save this file here. Let's say, for example, as hello.java. Let's say, for instance. Now, this particular file, which is hello.java, will let's just create a class called hello. As we know, the class name should always be the same as the file name, which has the main function. So, and it should be public because we are accessing it. from outside the class. We know all these basic details, so let's just move ahead because we want to focus on what is more important within the round of interviews that we are supposed to face. So within this class, let's just say we have something like public static void main with string arguments. Now, let's say all I'm doing here is just printing something on the screen, just printing something. Let's say hello world. Now, if I go to the directory where this particular file is stored, which is hello.java over here, if I show this particular file or this particular link to you, now let's try compiling this file first. So let's go back to our compiler terminal and let's try compiling this. So let's just do java c space hello.java. So the moment I compile this particular file, you get a class file. So you know that this is compiling. This particular step is a compilation step. We get to know this right away. It's not interpretation here, it's compiling. I'll just point this out. Please note this to everyone. It's not just interpretation, it is compilation. So we are compiling a program and you're getting an output file over here. So this file, input file that is there, is compiled and you get your output file to execute. But there's one more step here. This is not the direct output file. This is also called bytecode in Java. It's not the file that's going to execute. The file that's going to execute, it is the file that's going to execute, of course, but it's not executing directly. So what happens is this bytecode file, that is .class file. Also to note, if you create 10 class files or if you create 10 classes in your code, it's going to create 10 class files. For each class within your Java file, it's going to create a separate class file here. So going ahead from here, now let us move on to the next part of this. So in your .class file, what basically happens is when you run it, it gets interpreted. What I mean by interpreted is this particular class file, each line is taken, it is executed, and then it goes to the next line. Each line is taken from here, it is interpreted to lower level language as required, line by line, and then execution happens. It doesn't execute this as the low level file directly. So this is why we call Java as compiled as well as interpreted language. So that is why when it comes down to just-in-time compiler, this not only compiles but interprets your entire Java programs as well. And every Java program that runs, it must run in a virtual machine that is called JVM. And JVM is the link, as we learned earlier. Any program that runs, the program runs on top of JVM, which runs on top of Java. So program runs on top of JVM and JVM runs on top of Java. And this JVM ensures that this program doesn't access, runs on top of OS. This JVM ensures that the program doesn't directly access any part of the operating system, whether it's memory or anything else. So that is the main use of JVM. It creates a virtual environment for your program to run safely without affecting the rest of the system. So that is exactly what this virtual machine JVM does. So followed by the virtual machine JVM, there's one more thing that we have that is called Java runtime environment. So a Java runtime environment, I'll just point this out in short, is just the set of libraries, nothing else. It's just a set of libraries which are used to run a Java program. So Java program runs on top of JVM, yes, but this particular JVM also requires a set of libraries to implement and run a Java program. That is done by JRE. So JRE implements JVM and JVM runs JIT, where the bytecode is interpreted. Now, on the other hand, followed by JRE, you have one more thing called JDK, which stands for Java Development Kit, where you can create your own Java programs. So if you want to run Java programs, you only need to download JRE, because JRE itself consists of your Java virtual machine and just-in-time compiler along with other libraries to run the program. If you want to develop your own Java programs, you need to download JDK. When you download JDK, you can develop as well as run programs in it, because it has development libraries plus JRE plus JDK, plus JRE plus JVM plus JIT. All of these are available in Java Development Kit. That is basically what is happening here. So with this, let's go ahead and let's move on to the next part. But before that, let me just give you guys a fair bit of notes to understand and note this very clearly. JIT is just a compiler to load, which just runs your program by interpreting it. Now JVM, it helps load the bytecode, run it, load the bytecode, and provide a secure environment to run your Java program. This is basically what it does. And to run Java program, you need libraries. That is provided by JRE, which consists of JVM as well as JIT within it. So followed by this, finally you have JDK, which is Java Development Kit. This consists of set of libraries as well as development environment to create and compile Java programs. So this is often what we as developers use, because we are supposed to create our own Java programs. Now there are multiple versions of Java JDK, the multiple releases or versions or editions as you may say. There is Java SE, which is standard edition. There is Java EE, which is enterprise edition, and there is Java ME, which is micro edition, not mobile edition. So Java SE, which is standard edition, is used to create your simple programs to run it on your desktop and so on. Java Enterprise Edition is often used to create huge applications for companies, particularly like using Angular and so on, or Hibernate struts and so on. And Java ME are often used to create mobile applications. If you remember, long ago there were Symbian phones by Nokia, which basically ran on top of Java based mobile applications. So these are just the basic things that we need to know before starting coding within Java. Now let's move ahead from here over to the next part in the basics of Java. Followed by this, there are a couple of things that we need to know before continuing ahead. Java also doesn't have const keyword. Const keyword is replaced in Java using another keyword that is called final. So there are many different meanings for all of this, and all of them are basically something we need to learn and know very well. So let's try doing this. Now just remember, when we talk about classes and objects, Java has constructors but no destructors, because any destructors, whatever it is, it's taken care internally by using automatic garbage collection, which is done by finalize keyword or finalize function. Now let's go ahead with some basics here. So we already know all the object-oriented programming concepts from our previous sessions, that is from C++. So I would not want to go through these basic object-oriented programming concepts. Instead, we will go through the basic terminologies that we need to know in Java and directly go within a little bit of important questions that are often asked. So we'll not go through the basics of object-oriented programming because it's very similar to what we have learned in C++ itself. Now, let's take a couple of examples to begin with here. Now, C++ had this pointer. So we know back in C++, whenever we called object.function, and we had that function declared or function defined here, within the set of brackets, the address of object would be automatically sent, which will be received here as a pointer called this. But in Java, I cannot use explicitly pointers. I can't explicitly use pointers whatsoever. So that means I cannot send address of A whatsoever. So instead, there should be a different way how it is sent. So in this case, when the value is sent, you only access it as this, as a name, this dot variable. Because there are no pointers, the way it is performed is slightly different. This is a keyword. Implicitly, it's a reference variable. I get that we don't have reference variables explicitly as well, but this is an implicit reference variable. So its reference is sent, its object is sent, and we receive it as a reference variable called this. So whenever I want to access anything about A, I can just use this dot A, because we have already learned how reference variables work in the previous session. So it performs this internally, not externally, and we should also know that we can't use reference variables or pointers externally as well. So Java replaces it with this keyword, which internally works as a reference variable. So these are just a couple of basic things we need to know. But let's go ahead from this over to a little more important things. That is often asked questions when it comes down to keywords. There are a couple of keywords where you can get a lot of questions often when it comes down to Java. They are, in Java, static keyword, and followed by static keyword, you have another keyword called final. So what do they mean? What exactly they mean? These keywords have different meanings in different scenarios. When an interviewer asks, what do you know about Java? Do you know final keyword? You shouldn't just say, yes, I know final keyword, this is what it does. You're supposed to explain what are the three different ways in which final keyword is used. What's the meaning of these different ways? And how exactly does that work? So let's give this a try. So when we talk about static keyword, there are three different ways by which I can use static keyword. So let's take this for instance. In short, I'll not be going in detail within this because it's something which we can just go through the basics and we'll be able to understand very well. So when we talk about static keyword, you can have static block, or I'll just point this out. One, you can have a static block. Two, you can have a static variable. Three, you can have a static method. And four, you can have a static nested class, nested or inner class. So when any interviewer asks, like, how do you define a static keyword? You know static keyword in Java. How exactly would it work? So the basic idea here is static, when you use it in different scenarios, it has different meanings. Let us understand what is the different meanings here. So I'll just give this an example. Before that, we did not run the previous program. Let's just run it for our understanding. So since when I run the program, I'm running the class file, not the Java file. Always remember, we are running the class file. So I'll just have to type Java space hello. It will automatically search for the class file. I don't even need the Java file when I run this. Even if you delete this, it doesn't matter. So it's just something we should just know. So let's just run it. It prints hello world as expected. Now let's go ahead here and slightly work through a few things. Now, first thing is something called static block. Let's see what is static block. See, a static block is a set of code in brackets that you write with static keyword behind it. That's it. Static, let's say system.out.println of let's say static block number 1. That's it. Now let me copy the same thing out here and paste it after main, and let me call it static block number 2. Now when I execute this, we know only main is supposed to execute, but there's one thing we don't realize. By default, automatically, anything that is there in static block gets copied to main as the first statements. So static, there is one static block here, another static block here. In the same order, it gets copied, or it gets moved also, you can say, to main. Even if you're writing it after main, it doesn't matter. All the static blocks, whatever you have, get copied to main in the same order they are written, and it starts executing from main itself. Now main has these two statements to begin with, so main starts from here. It's not that static blocks execute before main. It's always that content of static blocks are copied to main before executing. That's why when we observe this, our output here is static block number 1, static block number 2, and then hello world. So with this little idea, we got to know how static blocks work. That's the first thing. So followed by static block, let's now look at what is static variable. Now we know this. Static variable, we know this from long ago in our session. What we have learned when it comes down to static variables. So static variables are not deleted until end of the program. They're accessible only within their scope. And all static variables, when it comes down to C++ and Java, they belong to class and not objects. So static variables behave differently outside a class and inside a class. So outside a class, there's only one copy for whole program. This we know. So inside a class, again, it's the same thing. There's only one copy for whole program as well. So where does the difference come up? When static variables are inside a class, let's say we have one more class here. Let's call it as class A. So in this class A, also syntactically, I hope everyone's able to just observe and understand simple things like there's no semicolon here in Java after classes end and so on. These little tiny things, tiny details. Now, let's say we just have something like static int A. Now, the thing here is, if I create two objects of class A, let's call this as X instead. So if I create two objects of class A, let's create one equals new A, and let's create another one, A2 equals new A. Now, the idea here is static variables have same, or in this case, static variable is the same for both the class. A1 also has only one X value, A2 also has only one X value. Now, I remember in our previous session that I stated that static variables of a class are different for each object, but when it is static variable, they are not different for each object. For all objects, it's the same variable. So if first object calls it, it's the same thing. If second object calls it, it's the same variable. There's no difference. So if first object modifies it to 10, it is 10 for the second object as well. This is basically what static variable means when it comes down to this. So followed by this, the next thing we need to know here is, let's go ahead for the next part, that is static method. When we talk about static method, the idea here is it's just a function with static keyword. So in simple terms, for any function, if you write static behind it, that is basically considered to be static method. And just like static variable, static method does not belong to a to an object, and rather belongs to the class. This is the basic difference. So static method doesn't belong to an object and belongs to a class. So there are some basic rules that you need to know. Static methods can only access static variables. Static methods cannot access non-static variables. The reason for this is because static methods are callable by the class without any object requirement. So you can call static methods without creating an object. So the best simple example for this is one function we often see, that is main. It's a static function. What does static mean? Static function means that you can call this object without using, or you can call this function without using an object of type hello. Now, when will a program run? When we start main function. Now, so we know a program runs when we call main function. Can I call main function without going into this class? If I need to call this main function, which is a part of this class, I need to create an object of this class. If I create an object of it in main, like let's say hello h equals new hello and everything, in that case, will this line execute? No. Why this line won't execute? Because for me to go into this function, I need to create an object of this class. But I don't want to create an object of this class, because when I'm accessing main from outside the program, I can't access this. So that is why we use static over here. Now, we'll continue this session in just a minute with just this one tiny break while you just go through these little concepts. So going ahead from here, let's just try going through this as quickly as possible. Now, we got to know that a class can have static variables and a class can have static methods as well. Now, the difference here is a static variable can be called directly. This variable can be used directly with a class name as well as object name. Similarly, static functions, if I create something like static void fun, it can be called from object, that is a1.fun, or directly from the class as a.fun as well. So the basic point here we just need to know is static variables can only be accessed if they are private. For example, Static variables can only be accessed outside the class using static functions or static methods, without which static variables cannot be accessed outside the class unless they are public. That's the basic idea. Now, followed by these three static keywords. As static block, we just got to know that every static block executes when main function begins. So they execute as the first line of any function to begin with. Now let's go ahead from here over to the next part. The next part we should know and be very clear about is finally static class. Now there's one little thing. A class cannot be static. A class cannot be static whatsoever. That will give you an error while compiling. Only an inner class can be static. You can have a class, and within that class you can have one more class called inner. Let's call this outer for our reference. Only this inner class can be static. And the concept of static inner classes are: a static inner class must have only static variables and it must have only static functions. There are nothing else that an inner static class can have. So the basic point I'll just point out, I'll just state this and write this for our easy reference: a nested static class. So only an inner class can be static, and static inner classes can only have static methods and static variables, because a static inner class doesn't require an object to call it. So there is no requirement of an object to call it. So I'll just take this example if you would want, in short. So again, as always, they can't access any non-static data. So let's just take one simple example. Let's take a static int, let's call it as date equals 27 here, and let's just try printing here, system.out.println as date is, we'll just add the date that we're supposed to print. Now let's see whether this works as expected. Now all that I'm doing here is to access this inner, I'll just create an object of this inner class. Let's see whether we can try it out. So outer dot inner, let's create an object called oi equals new outer dot inner. Now all that I need to do is just call oi dot okay, this, let us put it in a function called static void fun. Let's see what exactly happens over here. Let's give this a try, and first let's see whether this works. There's one slight change that I will be doing to whatever I have typed earlier, but let's just first give this a try. The moment we try this, we get date is 7. Now if I remove static, however, if I remove the keyword static, however, this static class has a non-static function. Even though it has a non-static function, it is still accessing static variable. Let's see whether that works. Java C, it does work. So the basic difference here is, let me just point out, because I was going through multiple programming languages. So static nested class, only an inner class can be static, and static inner classes can have static as well as non-static methods, but they can only access static variables of their outer class. If it's a non-static variable, however, of the outer class, the inner class cannot access it. So it will just tell you in a short way stating non-static variable date can be referenced from a static constant. Just as we know, anything that is static, you can't access non-static in it. If it's a static function, we can only access static variable. If it's a static class, we can only access static variable as well. So that is the basic idea when it comes down to static classes, or in other words, static nested classes, because static classes don't exist. So this is one of the most common questions you can expect. Followed by this, the next common concept from which you can expect questions is this basic keyword called final, and there are a lot of different ways questions can be expected from this. Now final keyword also exists in multiple ways. You can have final variable, you can have a final function or final method, however you want to call it, or you can have final class, not just inner class, final class itself. So we don't have a const keyword in Java. We don't have any keyword called const. So any variable that is specified as final variable is constant by default. That's the basic idea. Final variable are constant by default. Now final method, when we talked about final variable, now let's talk about final method. Any method that is final cannot be overridden in its subclass. So when they ask in interview, you know Java, so tell me about this keyword called final in Java. What does it do? How does it work? So you basically have to explain like final keyword works differently when you put it as a prefix to different kind of data. So if you put final before a keyword or before a variable, that's gonna be a constant value. If you put final before a method, a function, that function cannot be overridden. Overridden as in, let's take this for instance, let's call this as class base, and let's say we have a void fun in class base, where we are just printing, let's say for instance, in base. And let's create inheritance over here. We already have gone through C++. In Java, the only difference in inheritance is we have extends as the keyword. Now, when you inherit this base class function is not final. You're writing a base class function here and you're overriding it. Overriding this base class function in subclass. This is valid, yes, but if the base class function is final, that basically says that you can't override this function in its subclass. So any base class function that you have, you can't override it in your subclass whatsoever if it is final. This program will compile without any error. I'm not going to print anything. We just have base class function, subclass function. I'm just going to compile the program. There's no error, it will compile. But when I make the base class function as final, it won't compile, and it's going to say that fun in sub cannot override fun in base because overridden method is final. So if you don't want any particular function to be implemented in subclass, and that function itself must be shown everywhere, make it final. So where do we use it? Again, let's go back to the examples of bank accounts. If I have a bank account class, and under that we have savings account, current account as always, it makes sense to create show balance as a final function in balance account, because show balance is same whether you use from savings account or from current account. So there's no need to implement it separately here. You can directly write it as final. So these sort of little things, little examples are something that we need to know. Followed by this, there's something else called final class. So a class which is final cannot be inherited. Now we are able to inherit base class to subclass, but if I make base class as final, let's remove the final keyword from the function. If the base class itself is final, you can't inherit at all. Inheriting itself will give you error. So it says cannot inherit from final base. So this is how final keyword works with different meaning in different cases, and it's something that is very important for us to know. And there's one more thing that we really need to know in this, that is compile time and runtime polymorphism. Now we have already learned this. This same thing can be asked in different ways. So compile time polymorphism is also called early binding, and runtime polymorphism is also termed as late binding in some case, because data is bound to function or class, whatever it could be, during runtime, that is late. Here it is bound during compile time, which is early. So the same thing can be asked in multiple ways. It can also be asked as, on the other hand, static binding and dynamic binding. During runtime, it's dynamic; static, it's constant during runtime. So it can be asked in multiple ways. It's just the same thing. So we should not worry about that much. So let us move ahead from here. And now let's go on to the crux and the most important part of interview questions that we expect from Java. So one of the common question is, in Java, what are abstract classes? And what are interfaces? Now let's just try learning what these are, and let's just look at a couple of important interview questions that can be asked, because they may ask you what is the difference between an abstract and interface. If you just say both abstract or interface are used for data hiding and not know the entire difference, it doesn't make much sense. So let's try learning what exactly can be done. So the basic idea is abstract classes provide any degree of abstraction. When I say any degree, what I mean is 0% to 100%. Any degree of abstraction can be provided. Interfaces provide absolute abstraction, that is exactly 100%, nothing less than that. Let's just see how does this exactly work. So interfaces are not classes. That's the first thing we need to note and remember before going ahead. So a class with the keyword abstract behind it is basically an abstract class. And for an abstract class, you cannot create objects. You can't create objects. You can't instantiate them whatsoever. But you can create, however, you can have constructors, because we learned in our previous session, when subclass object is created, it's gonna automatically call constructor of base class as well. We learned how that happens, how to solve it, even with diamond inheritance problem as well. So the basic idea here is abstract classes provide any degree of abstraction, but the point is, in abstract class, you cannot create objects, although you can have constructors. And there are a lot of other rules which are not so important for us at this point of time. Let us only focus on an example to learn how they work and to learn how we can answer them in interviews. So let's take this one example. Let's create an abstract class called base. Now, in this abstract class, as I stated earlier, it can have any degree of abstraction. So that means I can have a regular function as well as abstract function. For those who are confused about what is this word abstract, abstract basically means to hide. For now, let's just remember this. So in this case, I can have a function which is hidden, which has nothing in it, or I can have a function which has data in it. I can create a function called void fun1, where I can print something like in fun1. Similarly, we can also have an abstract function, that is abstract void fun2, for example, where we can just write system.out.println in fun2. Now, here's the thing. When you try this out, you're going to get an error, because abstract functions are not supposed to have any body within them. So here's the simple idea. I'll just explain this. Abstract functions do not have any data. That's basically why it's called hidden. In short, abstract functions don't have any data whatsoever. So I've supposed to add these? Yes. So abstract functions are not supposed to have any data. So it's just a semicolon. That's it. This is just an abstract function. So why do we need abstract functions? In case whenever you implement it. Let's take the same example of bank accounts. In bank accounts, I can have a final method called show account, show balance, because showing balance is same for all kinds of bank accounts, whether it is savings account or current account. But when we create an account, creating account is different in savings account as well as current account. And creating account is an essential part. It's a compulsory part in both current account as well as savings account. It is absolutely compulsory. Since it's compulsory for both savings account as well as current account, what we need to know, understand, and remember here is that this create account, you don't need to write it in bank account function at all. You can make bank account function as abstract. When you make it as abstract, you can have, I'll just point this out, you can have an abstract function in bank account called create account. When you have an abstract function called create account, there's no statements in it that must be implemented by any class which inherits bank account class. So the idea of an abstract class is here, any class that inherits an abstract class must, I'll just point this, must implement or must override the abstract functions. If they don't create abstract functions or override abstract functions, you get an error. So here, if this is base and if I create a subclass out of it, let's just call it as class sub extends base. So in this case, we must have, whether you have void fun1 or not, it doesn't matter. There's no point about it. But you must declare fun2 and write statements within it. If you don't, it gives you an error because any class that extends abstract class must implement abstract functions. So with this, I can take this as bank account. And here I can say void fun show balance and just print something like 100.0, let's say for example. And we can just have an abstract function called create account. And when I inherit this to something called savings account, also when I inherit this to something called current account, I must implement this abstract function. If I don't, I'll always get an error. So here I'll just try running this. Let's see what happens when I compile this. It gives us an error saying missing method body or declare abstract. So the point is, you either have to create this void create account function here. If you don't override it, you need to make this class also as abstract, stating that it can have abstract functions as well. Because this is abstract here, it will also become abstract here if you don't declare it. If you don't write any body, or even if you don't write this at all, even then it basically gives you this error saying savings account is not abstract, it does not override the function. So let us go back and just create the function stating that, let's just call it as, let's just create empty brackets. This is, even though it's empty, we have implemented the function. So now you don't get any error. So this is the basic idea of how abstract classes work. So abstract classes can hide data to a certain extent or hide data completely as well. And this is the best example that I would always state when it comes down to this in real cases. So in interviews, always provide with such real case examples, which always helps the interviewer get to know that you know as well. So let's go ahead from here, go to the next part. Now let's go to the next part, that is interface. Now, in simple terms, interfaces provide complete abstraction, 100%. But there's one problem. Interfaces are not classes. They're not classes. So you cannot extend them. They're of a different type. To inherit them, you use keyword implements must be used. That is the basic difference. So let's just try this out as quickly as possible for us to just take an example to understand. So here's the basic idea. Let's say instead of abstract class, I'm going to make this interface. If I make this interface, instead of extends, I need to use implements because it's of a different type. It's not same as class. Same type to same type inheritance, we use extends. Different type inheritance, we always need to use implements. So from here, let's observe this. Now, I can't have a regular function at all in interface. I need to remove the show balance as well because interface will consist of only abstract functions. And even if you don't write abstract, that is also fine. By default, every function is abstract for interface. You don't even need to write abstract keyword. So this is the simple thing that we need to know. But there's one thing you need to know. Whenever you implement an interface function, it must be public. Whatever you're implementing from interface must always be public. So it says attempting to assign weaker access privilege was public. We should always remember it must always be public when we inherit from an interface. So with this interface, you can get one advantage in Java. So this is where your question comes up. How do you implement multiple inheritance in Java? You have it in C++. How do you implement it in Java? So the point here is in C++, you have a base class 1, you have a base class 2, and you have a derived class. So when both base class 1 and 2 have the same function, and from derived class you're calling it, it doesn't know which one to call. But here in Java, you don't have multiple inheritance, but you can implement multiple base interfaces. Let's assume B1 is one interface, B2 is another interface. When you implement both interfaces to the other class, that is D, here's basically what happens. This particular object, this particular class knows here that B1 may have since these are interfaces, they will only have abstract functions. We should remember this. They will only have abstract functions. Now, B1 may have an abstract function called F1. B2 also may have an abstract function called F1. Now, both are abstract. Both don't have any statements. If both don't have statements, will the derived class get confused which one to access? No, the derived class will never be confused because they don't have statements at all. Since they are abstract, you need to implement, you need to override it in derived, and whatever you override, that itself will be executed. That is how multiple inheritance is implemented using interfaces, because base interfaces do not have any statements in the functions. Since there are no statements, they are abstract. Since they are abstract, there is no confusion, there's no ambiguity. So the basic idea is, since they are abstract functions, there is no ambiguity within derived class. So these are the basic points that we need to know when it comes down to Java. This is for basics of Java. Followed by this, a couple of other questions are also commonly asked. One of the questions, most important question is, what are collections in Java? What do you know about collections in Java? How do collections work? What's the use of them? You can be asked these questions in any way whatsoever. If you guys remember, in C++, we had something called STL. STL was Standard Template Library, which had a set of code already created, and you just have to call the functions in it. Same way, even here, you have a set of code in collections, which you can directly implement. So there are things like list, queue, dequeue, array list, linked list, hash set. There are so many which are all part of collections, and you can implement them directly. You can inherit them and directly call their functions. So in a function, let's just take for example in queue, or let's just take a simple case in stack. Push, pop functions are all created by default, or all already created. All that you need to do basically is just run, or is just implement those classes and utilize functions in them to create your own stack, to add elements to stack, to iterate through stacks and everything. That is basically what collections are for. Now, I will not be going through detailed coding when it comes down to this right now, because in interviews, you're not in these interviews which we are focusing on, you will not be asked them, but instead you will be asked questions on how these things basically work. So you have previously defined set of code in a class which you're just implementing or inheriting to run your own collections. There are so many of them. I'll just give you one small example just to observe, because there won't be any coding here. I'm not going to take more examples, just one very tiny example of array list. So array list is basically, in short, I'll just state, array list is just a dynamic array whose size can increase to anything. It's very similar to what we learned in C++, which was vectors. Now, it's very similar to vectors. Let's try creating one very simple array list. So if you want to create an array list, you need to know that everything in these are stored in a certain set of packages in Java. So what are these packages? Again, this is an important part as well. What is a package? We'll get to that in the next step, in the next question. But you can import packages like this. There are a lot of inbuilt packages which are under Java, under some folder called util, and you can have something called array list here, or so on. I'm just going to implement everything from here so that I don't have to waste much time. So all you need to do is just create an array list here. Array list is a part of java.util package. So array list of any type. We can create string, we can create integer, we can create anything we want. Let's just create something of string, and we'll just call it as al equals new array list of string. Once this is created, it creates our new array list, and we can use inbuilt functions. To get to know inbuilt functions, the best thing to do is go to official Java Oracle documents. So you can just search for Java Oracle documents collections here. So I'll just take this particular link. In Java SE Platform 8, you'll get to see this particular collections. Now you can see there are so many of them. There's abstract list, there's abstract set, there's linked hash set. There's so many things. What we are implementing is array list. So I'm going to click on this, and let's see what exactly do we have here. So you can see there are a lot of functions. There's something called add, there's something called add all, there's clear, there's clone, there's contains, ensure capacity for each. There are so many functions that you can use. You can learn what each function does just by clicking on it, and it will give you an example code as well. Once you scroll down and go through it, you will be provided with example code as well, which you can learn how exactly it works. So for each function, you can just get to know what is the input, how it works, what is the output. So we're going to just use the same add function that we saw there. So I'm just going to take al.add. We need to add strings. Let's say this. And similarly, you can use al.add is, and let's say we also use one more thing, al.add array list. So let's just try to print it out. Let's just take system.out.println of al. Let's just give this a try. Nothing complicated. Let's just compile it, run it. It just prints the entire array list. You can also print individual values in various ways. So this is basically how your program works, or how, in short, array lists work. So let us go ahead from array lists over to the next part. Now, the final part that we need to know when it comes down to Java, which is hugely important again, as we should know for interview questions, is packages. Now, this particular topic, package in Java, is simple and it can be explained like this. So, think about this. In C++ or in C, you have header files. Each header files has many functions. Header files have many functions. Now imagine there are many header files like this in one folder. There are many other header files on math related in one more folder. There are many header files in business related, for example, in one more folder. So there are multiple folders where there are many header files. Now all these folders are in a different folder. And this folder is your package. So I'm not saying that there are header files here. What I'm saying is a package is generally a directory which consists of many other directories, or it can directly consist of classes. So there are no concept of header files in Java. Instead of header files, we have packages here. So package one, package, or you can have inbuilt package or inner package. Each package is basically considered as a folder. This folder can have class files directly. So a package name can directly be a class name itself. You can directly import, when you import that package name, that will import only that class name because that package only has one class. Or in some cases, there's a package called Java, which has many packages inside it, many other folders inside it. Inside Java, you have AWT. Inside Java, you have swings. Inside Java, you have util. Inside Java, you have string, and so on. Out of that, we go to util. Within util, you have many other packages again called array list and so on. Within this, you have many classes which has functions which you can use. So if I implement array list, if I import this package util and import array list package from there, or set of class, it will have many functions which I can use. One of those functions is add. So this is the basic concept of packages. A package, in short, is a group of other packages, that is sub packages, or classes or interfaces combined together. There are many such packages. They will help ensure that all your common things are stored in one place and can directly be imported and accessed in your program. So this is basically how packages work in short. So with this, I will be ending the most important questions when it comes down to Java. From here, let us move ahead to the next very important part that you can often expect in interviews, that is data structures and algorithms. Now, we all know this is a huge part when it comes down to interviews. They will generally ask, how good are you with data structures? Which data structures do you know? Which is the best data structure to use in a certain situation? And so on. So we will try to work through this and understand what they are. So let's just first start with something very basic. What is a data structure? So in short, a data structure is just a way to store and organize, or you can also say manipulate data. So what does this mean? A way to store and organize or manipulate data. I can store data in an integer variable. I can create a data, or I can create an integer variable a, and I can store a value 10 in it. So does that mean this integer is also a data structure? Because I can store a value in it, I can organize by storing it like this, I can modify it by changing it to 20, by changing it to -1, anything. I can manipulate it. I can manipulate it as well. So is int also a data type, or sorry, is int also a data structure? Yes. int is also a data structure, char is also a data structure. All of these are your primitive data structures. From these data structures, we create some complicated data structures through structures and unions, including arrays. Even array is a data structure, which is a complex data structure created through simple data structure like int. Using combination of this, we create another data structures like array. Using combinations of this, we can create something else called stack, or we can create something else called queue, which are used in different purposes, and they have separate functions of their own, like push, pop, enqueue, dequeue, whatever you may call them. So similarly, we can also use structure, which is also a user-defined data structure, to create linked lists or double linked lists and so on. So basically, all of these are data structures, and the major data structures we have are divided into two types. That is linear data structures and non-linear data structures. Now, what does this exactly mean? Think about this. Arrays, everything is stored in continuous memory location in a single line. It's linear. Let's see what else are stored in a sequential memory. So anything you basically store in a sequential memory location, you can consider them as linear. Think about stacks, think about queues, and so on. Even linked lists as well. They're stored in a linear fashion. When you talk about non-linear, you need to think about something like graphs. There's one here, two here, third city here, and fourth city here. So from 1 you can go to 2 as a city, 2 you can go to 4 as a city, 1 you can go to 3 as a city. This is not a linear data structure. It's a non-linear. And 3 you can go to 2, something like this. So such non-linear data structures like graphs particularly are a part of, in short, are part of non-linear data structures. So these data structures we use particularly, I'll just point this out, these data structures we use particularly to store data in a particular way and utilize it efficiently and effectively by the way we have stored it. So to understand this, the basic point we need to just know and remember is, when we talk about data structures, all data structures have something called time and space trade-off. Everything has something called time and space trade-off. I'll just give one simple example for us to understand this with an example. Because in interviews, if they ask you, if you state that I'm good at data structures, they'll usually ask, why so many data structures are there? Why are there so many data structures? Which one will you use at what point of time? Which data structures are you supposed to use, and so on. So when you get all these questions, there's one simple answer for it. There are so many data structures because each data structure focuses on one aspect in terms of time or memory. Or in other words, we also call it as time complexity and space complexity. To understand this better, think about this. I can either compromise on time or I can compromise on space. If I have a very small box that I have to transfer, then I can transfer a small box quicker, but I can't fit a lot of things in it. If I have a larger box, I can fit a lot of things in it, but transferring is going to take a lot of time, because a large box I can't transfer over a bike. A small box I can transfer over a bike. So there's some time complexity and space complexity as well. So if you focus on time, if you want to save time by taking a small box, you can't fit a lot of things in it. The space is less. If you focus on space, if you take a larger box, you can fit a lot of things in it, but there's a problem with time. So you need to compromise, or in other words, technically we call it as trade-off. You need to figure out what is the optimal trade-off between time and space that you are willing to do. So to figure out how to make the perfect time and space complexity trade-off, we need to use the right data structure. So how we choose the right data structure, how we're going to implement to ensure that we are using the right data structure to ensure we are saving time and space in the appropriate way. In some cases, you may not want to save space. Let it take however much space it requires, but you need to get it done quickly. For example, let's take a cab app. You need to ensure that it's of time efficiency. You need to ensure that whichever cab is there, that should get booked at the quickest. You should not worry about space initially, up to a certain level at least. On the other hand, take a different case. Let's say time is of not much importance, but memory is of very huge importance. Let's say mobile device. In mobile devices, because of less space in some app, you may be okay with it loading slightly later on, but you need to work on the space. So you generally use light apps, which load slower, but they save space. So this was just one example that I've taken, but in the next session, we will see what are the different types of data structures that are there, which one are we supposed to choose, which one are we not supposed to choose, and why exactly. So until the next session, have a good time and keep checking our channels for more content. We'll catch up in the next session while we go through more and more concepts. All right, so thanks a lot for joining us. Do check out more about our channel. If you want to go through more at any point of time, check out the description of our channel as well, and you can join our courses to gain a complete practical exposure towards placement-oriented training from aptitude, verbal, technical, all together. So we'll catch up in the next session. Have a good time.